Oh, we're going to talk about diffraction grating. So grating in Chinese is called 光照. So what does that mean? It means that in a distance, say for example 1 meter, you have 10 to the 6 slits, so 1 million slits. So in that case, the distance between the adjacent slits is equal to 1 micrometer. Okay, so for the diffraction grating, the constructive interference can be computed, can be considered this way. So this is the D between the two slits, the distance. And let's say if you're looking for the first one, that you have constructive interference. So then you look at this here, just like before, and we see that D sine theta is equal to delta x, which is the actual distance traveled. So delta x is equal to D sine theta, and then you arrange it. So not you arrange it, now you say then D sine theta, this actual distance, is equal to m lambda. So it's a multiple of lambda. And this multiple can be 0, 1, 2 for the constructive interference, okay, just like before. So this is basically 0 degrees, 360 degrees, 720 degrees. So now for the first, for the M1, right, M equal to 1, we put M equal to 1 there, we call that theta 1, then we can go ahead and construct what do we have in this case. So in this case, sine theta 1 is equal to lambda, so times 1 divided by D. And if the lambda, it's for the 400 nanometers, so which is the violet, right? So this is the visible light violet. And so we can put that in. So that would be 400 times 10 to the negative 9, and this is 10 to the negative 6. So you take the arcsine, so theta 1 is arcsine of this. So theta 1 is equal to arcsine of lambda divided by D, right? So then we compute it is 23.6 degrees, which is quite significant. So in diffraction grating, D is quite small, like in 1 micrometer. And so theta is no longer small enough that sine theta really cannot be approximated by the tangent theta, and it's not approximated by the theta itself. So in this case, if we also say that L is equal to 1 meter, so between here to here, L to here, that's the 1 meter. So in this case, tangent theta 1 is the opposite to the adjacent, so then that's equal to y1 divided by L. So you can compute the y1, which is the location of the first constructive to the center. So that is equal to y1, that's equal to L times tangent theta 1, which is 23.6, and that comes out to be 0.44 meter. So you can see this 44 centimeter is also fairly large. So you can see this is 44 centimeter in this case, and then m plus m equal to 2 would be, more or less double of that, but you can go and compute that. And so you can see they're fairly widespread in the diffraction grating. So that's the case of diffraction grating. And we're going to continue for another subject here. Polarization of light. So we're going to consider, like before, the ray, it can travel 360 degrees from source. So this is the light source right here. And it can travel in 360 degrees. So in Huygens principle, any point on the wavefront, it's a light source, right? So if you consider in the refraction problem, we have air and water. When you have a ray comes in here, it looks like it's one ray, but actually any single point can be a light source. So it can be actually traveling, have many different rays that can travel. Okay, so in this case, you can consider unpolarized light will behave such that you have E field in the 360 degree. Okay, so when you go through a polarization, if we think of in the mechanical wave like a rope. So if you shake your rope up and down like this, and then you give it a window, which is a slit, the narrow slit, right? So it's the narrow slit. And this mechanical wave can pass through here. But if you have this one left and right, and you still give it a narrow vertical slit, then this one here, left and right, will not be able to pass. So in the same idea, so this polarization is like in the sunglasses. So sunglasses basically provide light for you that can only allow half of the sunlight passing through your sunglasses. So in this case, if we have a polarization so that you can only allow this direction here to pass through, then all the others will be blocked. So then after the polarization, you will have this now. Okay, so that's all we're gonna have today. And we'll see you until next time.